All right, so my apologies, folks, but I'm not here today. So what we're going to have to do is do this distance learning style. So our objective today is that you will learn formulas for E. E is a number, by the way, and the continuous change model in order to solve continuous change problems. And we're also going to learn the properties of logarithms in order to simplify logarithms and solve logarithms with and without a calculator. I feel confident doing this. I feel like you guys are going to be okay with me being doing this video and you watching the video. I feel like it's going to be all right. You do have homework this evening, and we will check the homework next class. So we're going to be looking at page 585, 8 to 14, 16 to 20, and then page 592, 8 to 11, 13, and 16 to 18. So the first thing we're going to be doing is looking at formulas for E. There's basically two pretty popular formulas for E. One is PERT, or BERT, which is principal times E to the rate times time. Or it could be BERT, which is the beginning amount, E to the power of rate times time. And so that's one of the formulas. And we're also going to look at solving some continuous change problems. We're going to start very simply by looking at what E is known for. So this is our formula for the continuous change formula, and it is A of t equals E to the RT. R stands for the interest rate or the rate of change. T is the time. So depending on what your interest rate is, it's usually expressed in terms per years, and so then our T is in years. And P is the initial amount or the starting amount. Sometimes you'll see this written as B, E to the RT, and it just means the same thing. So what we're going to be doing is we're going to be solving some problems here, and it says $500 is put in a savings account, and we want to find it at an annual interest rate of 8%, and it's compounded continuously. So the first thing we want to do is we just want to find the annual yield. Well, the annual yield is kind of like the annual percentage rate, but because it's compounded continuously, you're going to get more. So when you just want to find the annual yield, what you're going to do is your principal is going to be 1. So in finding the annual yield, our principal is going to be 1, and then we've just got to figure out what our interest rate is. Well, our interest rate, they tell us, is 8% annually. So that's going to be our 8%, but we don't just use 8%, we make it a decimal, so that's 0.08. And then our time, because it's an annual yield, is 1. Because it's going to the first power. So all we've got to do to figure out our annual yield is use our PERT formula with P being 1. So we've got 1 times E to the 0.08 times T. And in our case, our T is 1. All right, so basically then what we're going to do is we're just going to type that in our calculator. So let me bring up my calculator. It's time for the calculator. It's time for the calculator. It's time for the calculator. So what I'm going to do is I'm going to take that interest rate, which was 0.08, and I'm going to take it times 1, and that's going to be my exponent. But to show you how to type this in your calculator, you got to find the E key. There's a couple of places you can find E. So looking at my calculator, I see over here by the 4 I have an LN key, and then in the LN key above it in blue is E to the X. So that's what I could use to type E to a power. If I just want to type E, if you'll notice over here on the division key, there's an E above it in blue, and that is the number E. All of the letters that are portrayed on here as alphas are in caps and they're in green, but this is the number E. So you could do second natural log, and we've got E to the 0.08 times 1, and that is our exponent. So we just press enter, and that tells us that my actual annual yield is 1.083287068. So we're actually earning a little bit more than 8% because it's being compounded continuously. So to find our annual yield, well, 1.0832 or 33. So we're actually getting 8.33% on our funds. So then the question says, okay, well, what if we have the money in there? So this time our principal is not going to be 1. This time our principal is going to be something other than 1. So I'm going to try, the yellow's kind of nice here. Our principal is going to be 500. Everything else is going to be the same. So our principal is going to be 500. Our rate is going to be 0.08. And our T is going to be 1 year again. So the only thing different is that instead of our principal being 1, the amount in our account after 1 year is going to be 500 times E to the 0.08 times 1. So we go back to our calculator. Okay, I'm going to do 500 second natural log, and I do 0.08 times 1. And this tells me that the amount in my account is $541.64. So I would have $541.64. So that means I actually earned $41.64 in interest. But 8% of $500 is $40. So I earned a little extra by having that interest right there. Now, as far as on my calculator goes, if you wanted to use that other E, you could do that, 500, and then do second divide, but now you have to do the caret key to tell it that you're using it with an exponent. You're still going to get the same answer because it's still E. Okay, but you can do it either way. Alrighty. So our continuous change model can be used a couple of different ways. So we've got a quantity or a principal that grows or decays. Now if it decays, what does that mean? Right, it's not growing. It's decaying at an annual rate, and the amount of the the amount in the account after T years is given by that formula. So what we're going to do is the same thing as we're going to do the same formula, but now we're going to have a time of 4.5. So for part A, our principal is going to be 500. Our interest rate is still going to be 8.5, or excuse me, is going to be 8%, so that's 0.08. And our time, this time, is going to be 4.5. So we type that in our calculator. We've got 500 E to the 0.08 times 4.5. And that's going to tell us how much is going to be in our account. So if we bring up our calculator again, so we bring up our calculator, and we're just going to type this in. So we've got 500, and I'm all about working smarter, not harder. So I'm going to do e to the x, and I'm going to do 0.08 times the 4.5. And this time I have $716.67. $716. Well, that's a terrible looking 6. And so was it 67 or 66? How did I round it? 66 cents. Sorry about that. So that's the first problem. The second problem says to compare this with compounded quarterly. So compounded quarterly, you're probably like, hey, what's the compound interest formula? Well, let's look it up. You probably don't remember it, so you're like, well, how would I find it? Compound interest formula. And there it is, the compound interest formula. So I'm just going to take a little snapshot of that and put that in my video. So there's my compound interest formula. So now I've got that. And so I need to know what my various things are. Well, it says that the principal is going to be 500. So I know that's going to be 500. So I'm going to have A equals, so this is for letter B, A equals 500 parentheses 1 plus the interest rate, which is 0.08, and it says it's compounded quarterly. Quarterly means 4 times a year. And so then that's going to be to the 4 times how many years? Well, the years are still 4.5. So that's my formula. And so now what I want to do is type that into my calculator. So I've got my calculator. I'm going to scooch it over so I can see what I'm typing. I got 500 parentheses 1 plus, and if you want to do it as a fraction, do it as a fraction. Okay? So I've got 0.08 divided by 4, close the parentheses, to the 4 times 4.5. And this time I have $714.12. So, do I make more money with compounded continuously? Yeah. How much more? $254. Not a lot more, but a little more. So, compounded continuously is just what it says. Now, the closest thing we get to compounded continuously is credit cards. And credit cards are really evil because they have such a high interest rate. So we'll talk more about that later, but one of the dangers of credit cards is the fact that it's such a high interest rate and how quickly it gets compounded. So we'll chat about that. But that's the closest thing we have to continuous compounding. This is the natural log. Now the natural log is the same thing as a regular log. Remember when we talked about log? And we said if we didn't see a number as a base for log, that was base 10? Okay, well the log base e is the natural log. So we can figure out, hey, I want to have $3,000 and I'm going to compound it continuously. So I can take the natural log and it would tell me what those are. So what I'd like for you to do is pause just for a second, pause the video. Yes, pause the video. Try these questions, and then we'll check them. Okay, so these are your answers. All right, so then the next thing we want to talk about today, this is how I actually did that last problem to find how much money they needed. They have $22,000. They want the car in 4 years. They need $24,750. So we're solving for R. So we divided, and we got 1.125 e to the 4r. So if we rewrite this using the log definition, that means the natural log of e, natural log base e of 1.125 equals 4r. And then we divided, so that gives us 2.9%. Okay, properties of logarithms. These you're just going to want to know, and you're going to want to be able to apply them. The property for any log, base b of 1 is 0. We already talked about that. The log base b of the number that is the base is 1, because 10 to what power equals 10? 1. E to what power equals e? 1. 7 to what power equals 7? 1. Likewise, if you have the base and then you have that base to a power, your answer is just the exponent. Remember, the logs are just the exponents. Remember, the logs are just the exponents. Logarithm properties: if you're multiplying the numbers, then you could just add the logs. If you're dividing the numbers, you can just divide the logs. If you have the log base b of a number to a power, you can multiply that power times whatever that log is. Because remember, logs are exponents. So when we were multiplying like bases, we added the exponents. When we were dividing like bases, we subtracted the exponents. When we had power of a power, we multiplied the exponents. So what we're going to do here is we're going to rewrite these using some properties. Well, this says the log of a product, which means I can rewrite this as the log of 6 plus the log of 11.
It is just comical.
So again, we're adding here because this is 3 times 5. So we're going to do the log of 5 plus the log of 3. Now this one's a combo platter because we're going to do the log of 3 plus the log of 2 to the third. But since that has an exponent in front of it, we can put that in front of the log of 2. Again, we can put that log 6 in front and then do the log of 6 minus the log of 5 and then distribute. So I'm going to put some practice problems on It's Learning for you to do, and you'll be great. Okay? Thank you.